Good afternoon, everyone. In the today's session, we would like to proceed regarding the physical effects of infrared rays. As we all know that you need to examine the different structural objects, different dimensional related, and various stand alignments internally regarding the overall dimensions and heat propagations. We could able to progress regarding the internal structural analysis in almost all the mediums, such as the gaseous medium, solid medium, and the liquid medium. We are being utilizing this infrared rays, which are these strong electromagnetic waves, which is used at a minimum to maximum of 750 to 4 lakh nanometers of its capability. In the case of its wavelength, has been propagated through the objects in order to examine the fundamental dimensions and its phase of offenses of the objects in different mediums. So, in the before class, we had a detailed discussion regarding the propagation of waves and the inspection related towards the heat offenses, where the manual involvement is not at all accepted or permitted in need to confine so. So the color indication clearly identifies that up to a maximum of 10 gigahertz of frequency. These are the moderate wave fluctuations in the case of this electromagnetic spectrum is propagated and identified only to a particular gaze length of the objects, and even the internal structure of the objects also with a blur-like situations, but not to a maximum clearance with respect to the internal agitations, that to an atomic range. While in the composition, if we have been considered to an atomic range or molecular structural deviations or bondings cannot be identified clearly. Later on, upon increasing its electromagnetic radiations capability, or in the case of this wavelength, which is normally utilized to a maximum of 100 gigahertz of frequency, as the scale notation indicates, the infrared rays plays a major role that completely will be propagating in almost all the mediums and in almost all the sectors, utilizing for the sector navigations for almost all the detailed analysis regarding the composition in the case of these gaseous fields, the liquid offenses in the case of this composition, and bonding between the molecules related to the solid objects, and exceeding the greater than 100 gigahertz of frequency, moving on with respect to 10 megahertz or 100 kilohertz. Greater on will confine towards the radio waves, which will be utilizing for the further agitations. Coming to its classifications, because of its wavelength having a shortest range, that will be ranging for the electromagnetic rays in between the wavelength of 770 to 1500 nanometers, confining towards its range for far and the long infrared rays having a large wavelength for propagating into the almost all the mediums, that 1500 to 12,000 nanometers are being utilized. So how the infrared rays are being produced? Basically, these are an temperature offensive range that will be happening at a maximum feeding assignment of conditions regarding the temperature zones nominally generated with different sources. The initial source it is the sunlight, from the sunlight, and next thing the gas fires. Particularly in this gas fires, inert gas plays a major role for getting the highest range of temperature, that too around this 2500 degrees centigrades to a maximum level of 3000 degrees centigrades of temperature. Nominally, we will be attaining this infrared rays that leads beyond the 1200 degrees centigrades of temperature. So the maximum in the case of the inert gases will be achieving greater than this 1200 degrees centigrades of temperature, as will be observing in the case of this iron carbide diagram also. 1147 degrees is the phase transformation zone towards the semi-liquid to the complete phase of liquid, that the molten metal will be getting carried, that too for high composition of the steel fence also. That's the strongest objects, the more ferrous content of objects. So for 1147 degrees centigrades. So more than that leads to 1210 degrees, 1400 degrees, 1310 degrees, 1400 degrees, a maximum. And inert gases, particularly having the oxidation process or reactants with respect to the oxygen, that is plenty available in the atmospheric zone, have the capacity of generating highest temperature, that is to greater than 1147 is confirmed, and next later on increasing a maximum of 2400 to 2600, like that, nearly approximately. Next thing is indeed to maintain the stable range of the temperature, coal plays a major role. Hence this coal fires also plays a major role indeed to stabilize the temperature. Next, the electric waves, electrical fires, which constantly provides with respect to an AC power supply. And hot water pipes will leads to a steam range of temperature holds with respect to the help of this coal fires or else this AC power supply. Nominally, we're having two different types of infrared lamps used. There is luminous infrared and non-luminous infrared. In the case of this luminous infrared, the generator emits the infrared radiations which are produced with one or more incandescent lamps, which consists of an wire filament enclosed with a glass bulb. Normally, that has been packed up within that particular environment with respect to the inert gases, and moreover, argon is the inert gas most probably preferred for heaviest enrichment of the temperature for attaining the range of high temperature, but the pressure should be confined. So in order to achieve a better temperature offense and that too at a low pressure rate, that argon gas plays a major role. Normally, in the case of this luminous, we'll be utilizing the argon gas. And that filament is confined with respect to a tungsten material, which is related for both heating and cooling agitations. Particularly for accessing the heat offense, the AC power supply is being passed through this filament, which produces heat and generates the infrared and visible radiations. Even by this phenomena, it leads to generate the ultraviolet radiations also. So where the wavelength of this propagation with respect to the temperature and a minimal accessing pressure will be very much equal to the infrared rays with respect to the ultraviolet radiations. That is varying in between 350 nanometers to 4000 nanometers of its spectrum. Hence, it's having the wavelength to a confining of a region towards the 1000 nanometers. So, moreover, with the least pressure case, 350 to 1000 nanometers of wavelength propagations can be progressed in the case of the spectrum. And in the case of this non-luminous infrared rays, the AC power supply is passed with respect to resistor wire. Normally, we'll be utilizing a combinational strategy with respect to an copper tubing or clay leads to an non-luminous. That's nothing but an for insulation we will be utilizing the material, and the internal passage we will be utilizing the other material, such as the communication channels we will be utilizing in our domestical purpose also. That will be coming under the non-luminous conditions. So if these radiations has been generated for the experimental vigilance or inspection techniques, for performing the inspection techniques, there will be some physical effects in the working area that to confinedly upon utilizing this infrared rays. So upon accepting the law of electromagnetic radiation, because of the some parameters such as the reflection or maybe the refraction or scattering objects, and even the observance related to the weakness of acceptance ratios, and due to the law of inverse square, etc. These are the some of the parameters that will be getting affected on the mankind upon the experimental processing. We'll be visualizing some of the parameters of offenses, physical offenses that will raises if a particular zones of this infrared rays has been utilized in the experimental case. That is nothing but if 350 to 700 has been of IR has been utilized with an wavelength at low frequency, and that too with the propagation of high temperature and low least pressure ratio, what are the parameters for hazardous situations may be erased. And if at all the wavelength or frequency range has been increased furtherly than the 1000 nanometers, and what will be the factors that will be confiding to, and what are the parameters need to be taken for eradicating such hazardous situations, will be learning in detail. So the heat production, these infrared rays produce some heat in the small tissues which they will be observing within the propagating environment. Most probably luminous, which is maintaining a maximum range of temperature. Indeed, to attain the high range of attainment with respect to the frequency in the case of its wavelength propagation, nominally a short and a luminous factors need to be utilized, because in the case of this non-luminous, the protection plays a major role. Nominally, we will be utilizing the clay material for its sandwiching characteristic that limits the temperature passage. So for that conditions, for that case, we'll be utilizing this luminous infrared radiations, which is having a frequency range in between 700 to 1500 degrees, sorry, 1500 nanometers. So will be suitable for producing the heat by utilizing any one of the technique, that is coal fired or inert gas utilizations, or else directly from the sunlight, as we have been visualized in the previous slide. How the heat is being produced? So it can penetrate to dermis and superficial subcutaneous tissues that are being having the material which is insulated, having the thermal capability of conduction, and even insulated utilized for transferring its heat by maintaining to a particular level, constant level. Most probably in these conditions, in order to increase the frequency levels and holding a particular range of temperature and moderate pressures within the radiation effects, it leads to an incrementing in its frequency of waves. Normally, that will be ranging in between 1500 to 12,000 nanometers. So, if you have been maintained to that particular range of frequency, then for about 2 mm, it can be used, and superficial damage, nothing but penetration will be increasing much more. And the degrees, nominally it will be increasing in its 1 to 2 degrees raise in temperature, but not a maximum agitations. And this elevation of temperature is depending upon the ability of tissues to absorb the heat, specific heat of the tissues, and even the thickness of these tissues. The absorption of this IRR directly depending on the factors such as the frequency or the wavelength, angle of incidence from the source, the distance of the source to the propagating condition, and for the frequency, or normally will be called as a wavelength in the spectrum considerations. This infrared rays with a wavelength which is having longer than the 3000 nanometers are observed, and by the moisture that is being presented in the skin. So this infrared rays, which is having the long and short in range, will observe by the moisture which is present in the skin, and that confined to reduce the absorption of the heat. So 11% of the short and luminous of IRR infrared rays, which are being observed by the glass materials, glass of the bulbs, which are being utilized within the equipment, and 33% is reflected from the skin. 56% is observed, or the 56% is erased, and 36% is observed in the epidermis or the body coverage. 10% goes very much deeper into the dermis, and if at all remaining is being scattered within the epidermis. And for the long range of this infrared rays, 36% is reflected, 20% is observed in superficial dermis, 16% is reaches the deep epidermis, 19% is penetrate up to the dermis, and 11% is observed by the glass of the bulb. Coming to its observations related towards the angle of incidence, which is analyzed from the source, such as generated point of view. According to the Lambert's cosine law, where the angle of incidence, which is determined that the amount of radiation is being observed by the object. This absorption, which at a 90 degrees incident ray is maximum, very much maximum, because a zero reflection will be progressed in the case of this 90 degrees of incident rays. If at all is there any angle of incidence or repose or reflection status will be getting considered for every 15 degrees, in the ratio of for every 15 degrees, absorption will be getting decreased by 3% nominally, and maybe increased to the 3 to 5% also. Coming to the distance of the source, it obeys the inverse square law, where the intensity of the radiation is varying within the square of the distance. Nominally, we can say that it will be moving to an 50% of the distance, which is nearer, or when it is compared with respect to short, a long range, that is furtherly happening. And regarding the intensity, it will be increases by 4 times, or maybe decreases by 4 times. In the case of IRR, in this particular situation, it is directly depending upon the thermal conductivity of the tissue, the density of the tissue, the specific heat of the tissue, circulation of the tissues. So, in what way these generated heat source, upon its traveling from the source to a particular zone, will be getting affected in the mankind. Coming to the physiological effects, it have an immediate effect of reducing the heat where the tissues are being observed. Coming to the physiological effects, first one, the vasodilation, nothing but the superficial blood cells dilate because of the direct effect of the heat within the object, and even the generated heat within that particular level leads to an liberation of histamine, such as disturbances creating with on the capillaries, that the heat regulatory center in the medulla, it signals the capillaries to uh, dilate. Dilate is nothing but decreasing its thickness upon the temperature rising. The nerve stimulation considers, that is, it stimulates the sensory nerves, and perhaps if this temperature has been increased, that decreases the gamma fiber activity. It leads to a decrease the pain at that particular affected zone in the body part, and even decreases the muscle span and promote the relaxation or clear cut blood circulation. And this vasodepression, when this 43 degrees, this will be getting afford for its relaxation constraint when the temperature has been raised than the recrystallization temperature normally we'll be calling in our mechanical stream. That's above 40 degrees, that is 43 degrees. And even it leads to an phagocytosis that promotes the healing of superficial wounds. And it leads to an supporting conditions such as carbon cells, and access heat can help in drainage, accessing drainage facility. That is nothing but elimination of the unwanted material that is nominally within the body, leads to the confinement of the kidneys, and purified blood will be pumped to the heart, and that will do different parts, and waste will be sent to the ureters, and that will be expelled outside through a form of acidic source. Pigments and the erythema, the repeated exposures with respect to these infrared rays will cause the skin problems such as the destruction within the blood corpuscles. Normally we used to call the biological term, that is erythema aberration. Decreased the blood pressure with the passage of these infrared rays in many areas for prolonged periods. The blood pressure will be decreasing due to the vasodilation, and even it leads to an peripheral resistance to blood flow also. Coming to the indications and contraindications. So how we can analyze these kinds of situations or symptoms, analyzing of the symptoms. So indications, the painful conditions will be occurred for both the generation of these infrared rays in luminous situations and non-luminous situations, used to relieve the pain and muscle spasm. Edema, it helps in the absorption of exudates, that is because of the capillary dilations. Healing of the wounds, nothing but expelling due to the vasodilation effect, which used to drainage the wounds and sinuses. Nothing but expelling leads to an waste material out from the infected area that relieves the much pain. Skin conditions, the red radiations make the conditions such as dermatitis. It's a condition in the skin where having the red color and in the form of swelling also. Normally we'll be calling as a slight allergy due to the bacterial formation or fungus formation of the epidermis. Will be usually calling as an SEZ. It leads to an damage to the eyes, which causes the cataract problems, leads to a blurred vision, loss of sensations, typically causes the failure to detect the excessive heat. It may result in the burns. And what are the techniques that are being existing for infrared treatment. So choices that are meant for two conditions, there is for luminous and non-luminous also. And for this, the apparatus should be in a perfect working mode, that should be kept in a preheating conditions at least for 5 to 10 minutes. It's minimum 5 minutes. And voltage emitter should be confided, and you have to ensure that lamps should with this emitting from 250 to 1000 watts are being utilized in the case of AC power supply for exhibiting the high heat and maintaining the frequency, particular frequency. And next, later on, the patient should be prepared that he should be very much comfortable for accepting the conditions and avoiding the undue movements, even though some of the heat projected areas leads to an irritation or irritation process at the infected areas, where this IRR is used to project. And before that, we should be taking the safety measures that protecting the eyes and rest of the body parts instead of propagating this IRR. And before moving on to this testing of the skin, whether that patient is is being having capacity of accepting this IRR and having a capability of non-scattering or not, and removing all the metal objects like rings and safety pins are much better, because those will accept the infrared rays very much quicker, and hence nominally used to find in the hospital zones also, that removing of the entire ornaments of any kind of the material it is, arranging of the lamps and the patients, setting the timer zone and monitoring it by projecting over that 10 for about 10 to 15 minutes. And for chronic conditions, it should be processed for 30 to 40 minutes. And normally at the end, we use it to cover the area with respect to a dry towel and removing of the lamp and for entromia, which is to be produced. So this is the procedure that is being progressed for the treatment by utilizing this IRR in the case of this medical orientation. Propagating with respect to the industrial sector, we'll be discussing in detail in the next class. Thank you.